Hello students and welcome to the virtual classroom again. Today we are going to learn how to solve quadratics with the square root principle. This is a great way of solving quadratics while maintaining precision. So you use this method if you cannot factor a quadratic easily using, it's not a simple trinomial or it's not a Messier trinomial that can be factored, and that means that you can't use the Xavier method to graph it and solve by graphing, and it also means that if you do graph it, your technology is going to give you a rounded off number where you lose precision. So this is the method you use if it's not factorable and you need to maintain precision. All right, so we're going to solve each equation exactly. So this word exactly most likely means you're going to have radicals in your answer, okay? So exactly means you're not going to punch in square root 5 on your calculator and write all that hot mess number and round it off, because then it's not an exact number, it's a rounded number. All right. So to do this, you have to draw upon your skills from the radical unit, which was unit 1 in pre-calc 11, and remember to draw upon those skills. All right, so we're going to look at example 1 where it says solve of each equation exactly. So for here, we're just going to use algebra, okay? We're going to move that 12 to both sides. We're going to isolate the square. The squared variable. So we're going to subtract 12 from both sides, and we're going to get x squared equals 48 minus 12, which is 36. Then we're going to square root both sides. And we're going to get that x equals the square root of 36. Now here's the thing, there's actually two answers. Remember, a parabola, which is involves a squared variable, has two sides to it. It has bilateral symmetry. And that's because the square root of 36 can either be a positive 6 or it can be a negative 6. Okay, so there's two answers there, right? Let's try another one. Let's try C. So we're going to subtract, pause the video and try it on your own, right? And now we're going to go through that. So we're going to subtract 2 from both sides. We're going to get x squared equals 27, and then we're going to square root both sides. And in this case, we get x equals plus or minus the square root of 27. Now, that's not the most simplified answer. So again, you're drawing upon your radical skills. We need to simplify 27. So you can remember that 27, the largest square that goes into 27 is a 9. Or you can prime factor it and look for a group of 2, and that's 2 3s. Regardless, this is the square root of 27 is the same thing as saying the square root of 9 times 3, which is the same thing as saying 3 square root 3. So x is going to equal plus or minus 3 square root 3. So if you need a little refresher, make sure you go back to that radical unit and kind of review simplifying entire radicals into mixed radicals. Let's try the next one. So you're going to move the 16 to the other side by adding it to both sides. You're going to end up with 3 minus c squared equals 16. You're then going to square root both sides. So here, 3 minus c equals positive or negative the square root of 16, which is 4. Okay. So then it's going to be, you're going to subtract 3 from both sides. I'm going to change that. I'm going to color code this. And you get negative c equals negative 3 plus or minus 4. You're then going to divide everything by negative 1, or multiply everything by negative 1, and you're going to get c equals 3, and again it still stays plus or minus because the plus became a minus and the minus became a plus or minus 4. that means C can equal 3 plus 4, which is 7, and C can equal 3 minus 4, which is -1. So here are our two possible answers right there. Okay. I want you to pause the video and try D. Welcome back. All right, I'm going to actually delete some of what I just wrote so that I can have space. I actually might just move it over there. I don't know why. I don't like deleting my work. All right, so we're going to do the same thing for here. So we're going to start off with a square root right away because the square was already isolated. So we're going to get 1 minus 2g equals the square root of 49, which is 7. So it's going to equal positive or negative 7. We're then going to subtract 1 from both sides. So we're going to get negative 2g equals -1 plus or minus 7. You're now going to divide everything by -2. Okay. And then you're going to get positive g equals a positive 1/2. And then it's just going to be plus or minus 7 over 2. Technically, 7 divided by -2 is -7/2, but remember it's positive or negative, so it stays positive or negative because both signs are possible. All right, so from here, you have to figure out what the two options are. So g can either be 1/2 plus 7 halves, so that would be 8 over 2, which is the same thing as 4. Or it can be 1/2 minus 7 halves, which would be -6 halves, which is the same thing as -3. And here are our two answers, 4 and -3. All right. So that's if it was a just one of your terms has a variable in it. Now we're going to look at putting what we just learned together with completing the square. Okay, these are actually really long questions, or can be really long questions. So I'm only going to do A and C. I'm going to give you the answers for B and D on the opposite side, if I still even included them. I did. And I'd like you to go through them on your own. And I'm going to tell you the answers. And if you can't get the answers to those ones, I want you to come into office hours or class and ask for help on those. Okay. So there's two different really scenarios for completing the square. So here you have A and C are both trinomials. You would have tried to solve by factoring, and you would have found that there's no way to factor this. And you would have maybe tried to solve by graphing. And solving by graphing for the first two doesn't necessarily give you an irrational number, but it might. So we're going to go over how to solve this with algebra, with completing the square, and maintaining precision. So for this one, if you try to find two numbers that multiply to 35 and add to -12, you're not going to find them. And so you're going to be like, okay, I can't solve by factoring. I need to complete the square. Okay, so just a little review of completing the square. You're going to take half of that middle term, which is 12. So half of 12 is -6. And then you're going to square -6, which is positive 36. You then, because you can't, so we're manipulating this, because you can't just willy-nilly add 36, you have to subtract 36 as well. So that doesn't change the value. And not forget that you had the positive 35 there. Okay. So now this stuff in here is a trinomial square. So we can write that as m minus 6 squared. The number that goes in the bracket is either half of that middle term, that -12, or it's the square root of 36. But you have to look at this sign to know what sign goes in here. Okay. And then we're going to group our like terms, our remaining terms here. Negative 36 plus 35 is negative 1 equals 0. Okay. And now we are right back to where we were up here with example 1b, and we're going to solve it the same way. So we're going to add 1 to both sides. We're going to be left with m minus 6. I don't know why I changed to purple. That was a mishit. Equals 1. We're then going to square root both sides. And the square root of 1 is positive or negative 1. We're then going to add 6 to both sides. And that means m is going to equal 6 plus or minus 1. So m is going to equal 6 plus 1, which is 7. And it's going to equal 6 minus 1, which is 5. So if you had graphed this one, you would have actually come out with precision, precise answers, but that's not always a guarantee. And again, sometimes you don't have a graphing calculator available to you. Okay. So let's try what happens when there's a coefficient. So it's a Messier trinomial. So for C here, you have something in the way. And when we went over this before, remember we just got the coefficient in the A position. We got this coefficient in the A position and we just moved it out of the way by dividing everything by that coefficient. And so we just had this 2 underneath the y on the right hand or left hand side just kind of being held out there until we were ready to deal with it. And we're not going to change our strategy on that. We're going to do the exact same thing. So we're going to divide everything here by 2. So we're going to be left with x squared minus 7 over 2 minus 15 over 2 equals 0 over 2. Now we're not actually going to calculate what 0 over 2 is because we're just holding that 2 over, I guess I should point this way, over to the right hand side. We're just holding it there for a wee bit until we're ready to multiply it back in where we need it. So we're being very manipulative. It's awesome. Okay, so now we're going to complete the square. So x squared minus 7 over 2, and we have to plus it with something. And we have to minus it by the same thing. And then it's going to be minus 15 over 2 equals 0 over 2. So here's where it helps to be fluent with your fractions. So I need to take half of this middle coefficient. Oh, I forgot to even, forgot the x. The x just kind of went away for some reason. Sorry about that. X. Oops. All right, so we just need to take half of 7 over 2. So that means we need to divide it by 2. That's the same thing as taking 7 over 2 and multiplying it by the reciprocal, which is 2 is the same thing as 2 over 1. So the reciprocal of 2 over 1 is 1 over 2. And then when you multiply your fractions, you multiply the top by the top. So 7 times 1 is 7. And you multiply the bottom by the bottom. 2 times 2 is 4. So 7 over 4 is what half of 7 over 2 is. And if you're paying attention, you notice all I ended up doing was multiplying the denominator by 2, right? Now I have to square this number. So 7 over 4, to get what this number in the bracket is, or in the 2 boxes will be, I need to square this number. So when you square a fraction, you're squaring the top and the bottom. So 7 squared is 49, and 4 squared is 16. So that is our lovely number that goes in here. Aren't fractions great? I love fractions. They're our friends. Okay, so now we have to deal with the smart board that I'm working with, but also we have to now recognize that that is actually a trinomial square because x squared is a perfect squared and 49 over 16 is a perfect square. So we have to put it into those brackets. So it's going to be x, because that's the square root of x squared. The symbol in the bracket is dictated by that middle term, so it's going to be a minus. And then the number that goes in the bracket here is that number that we found. We've already found it. It's 7 over 4, because we had to square it to get this, and we had to have this to get this. And it's the same number that goes in there. So the number in the bracket is half of 7 over 2, which is 7 over 4, or it's the square root of 49 over 16, which is the same number, 7 over 4. So now I'm just going to leave my fractions here because I know I'm going to I can simplify them now, or I can recognize that my next step is to multiply everything by 2, and maybe I just want to hold off. So I have completed the square. I have to get rid of this 0 divided by 2 on the right-hand side here. So I'm going to multiply everything by 2, because when you multiply a fraction by the same number that's on its denominator, it cancels out. So this is going to leave me with 2 times x minus 7 over 4 squared minus 49 over 8. I'm going to explain why in a second. Minus 15, because 15 over 2 times 2, again, cancels out the numerator and denominator, and it equals 0. Okay. I'm just going to do a little, I guess, aside to explain why 49 over 16 times 2 is 49 over 8. So we have 49 over 16, and we multiplied it by 2. Right? So there's more than one way you can look at it, but how I look at it is this is the same thing as 49 times 2 over 8 times 2. That cancels out and leaves you with 49 over 8. The other way you could do it is actually multiply 49 times 2. Multiply the top by the top, so you'll get 98 over 16, and then you'll have to simplify. Okay, they're both divisible by 2, and so then you would get 49 over 8. To me, this bottom one here is a lot longer and tedious, and if you can remember, hey, if I multiply a fraction by 2, it's the same thing as just having the denominator. So that's how I got it. I'm going to go back to the question now when my computer decides to join me. All right, so now I have these fractions. Now I do have to deal with these here, and I have a fraction being multiplied with a whole number, which means I have to find a common denominator. So this 2 times x minus 7 over 4 squared just gets to hang out for a while. 49 over 8 gets to hang out. And now I need to make this 15 to be over 8. So technically this 15 is 15 over 1. So I multiplied the bottom by 8 to make it a fraction out of 8, which means I have to multiply the top by 8, which is 120. So 15 times 8 is 120. And it all equals 0. So now I'm going to rewrite out again because there's no race, there's no prize for first place. And I'm going to subtract 49 eighths with a negative 128. So when you're subtracting and adding fractions, the denominator stays the same and you add or subtract the numerators. So negative 49 minus 120 is negative 169. All right, so now I am going to leave it in fraction form because remember we want exact values. We don't want to be punching that into our calculator and rounding off a decimal and losing precision. We're going to just move that whole fraction to the other side. So I'm going to be left with, no, so we're not going to subtract it. We're going to add it because it was negative. So the opposite of subtracting is adding. My apologies for that. And we're going to be left with 2 times x minus 7 over 4 squared equals 169 over 8. And now we have to get rid of this 2. So we're going to divide this by 2, which means we're going to divide this by 2. So I'm going to be left with x minus 7 over 4 squared equals 169 over 16. Remember, when you divide a fraction by 2, you're basically doubling the denominator. Okay. So now I'm going to take the square root. Woo, we're almost done. The end is in sight. It's a beautiful question. All right, and we're going to be left with x minus 7 over 4 equals positive or negative the square root of 169 over 16. So remember, when you square root a fraction, you square root the top and you square root the bottom. This is the same thing as saying the square root of 169 over the square root of 16. So the square root of 169 is 13, and the square root of 16 is 4. Okay. Keeping everything in fractions, we're going to add 7/4 to both sides. And that means x is going to equal 7/4 plus or minus 13/4. And isn't that lovely? They have the same denominator to make it easier for you. So x is going to equal, I'm going to write over here, 7 over 4 plus 13 over 4, which is going to equal, now we just add the top, that's going to be 20 over 4. And 20 divided by 4, remember, a fraction is actually just a statement of division. 20 over 4 is the same thing as 20 divided by 4, so x is going to equal 5. Okay. The other x value is 7 over 4 minus 13 over 4. So when we're subtracting or adding fractions, the denominator stays the same and we just deal with the numerator. So 7 minus 13 is negative 6. So negative 6 over 4 simplifies to negative 3 over 2. So x will equal 5 or negative 3 over 2. And that is our solution to that problem. Okay. I want you to pause the video here and try those other questions. I'm not going to go through all of them. I'm just going to give you the answers for them. If you can't solve them or get the same answers, I want you to come to class and ask for help. Okay. And this one, you're dealing with fractions the whole way through. So x equals 2 and negative 1/2. Yes, I wrote that down right. Yes, I did. All right. So now I'm going to apply the square root principle to problems. So how you can algebraically solve something. So this question kind of assumes that we've already done the rational expressions and equations unit that we skipped. But really it's just dealing with fractions and applying our fractional rules. Now I'm going to go over them, kind of crash course you on them. So 5 is added to an integer. So if we have if we read this question again, because I kind of lost myself there, 5 is added to an integer that is being quartered and then squared. The sum equals 9. Determine the integer algebraically. So if we let I equal the integer, we're going to make a mathematical equation with the information given to us. So 5 is added to an integer that is being quartered. So that means this integer is being divided by 4 and then squared. So this integer is not only being quartered, it is also being squared after it is quartered. It's not being squared first and then quartered. The sum, so 5 plus whatever this is, equals 9. And now we have an equation that is kind of taking up a lot of space in my work area. So I'm just gonna woochie it over here. I'm not even sure where that came from, so we're just gonna get rid of it. Okay, so the first thing we're going to do is we're going to expand our brackets. We're then going to, well, actually, no, we're not even going to do that first. We're not going to expand our brackets. We're going to isolate the square. Okay, so we're going to subtract 5 from both sides. And we're going to get I over 4 squared equals 9 minus 5, which is 4. We're then going to square root both sides. So I minus 4, because the square root of I divided by 4, I don't know why I said minus, I apologize. I divided by 4 squared, and then take a square root, they cancel out and leave you with just I divided by 4. And it equals positive or negative the square root of 4, which is 2. So this is the biggest point of this unit. When you square root something, it can be positive or negative. So there's two possibilities, which is why there's 2 sides to a parabola. Okay. We then need to multiply everything by the denominator. So we're going to multiply everything by 4. Okay. So I is going to equal 4 multiplied by positive or negative 2. Okay. So that means I will equal 4 times positive 2, which is 8, or it'll be 4 times negative 2, which is negative 8, so, or I equals positive or negative 8. And if you were to do the math, so a quarter of 8, so 8 divided by 4 is 2. 2 squared, so if it's 2 or negative 2, doesn't matter, because when you square it, it becomes positive. So 2 squared is 4, 4 plus 5 is 9, and it works in that equation that we constructed. So when you have a question like this, and again, this one kind of draws upon the rational expressions and equations unit that we skipped. But we're going to, when you have things like this, you want to get rid of the denominator to get, because you don't want your variable on the bottom. It's really hard to solve that way. So what you do is you multiply everything by what's on the bottom. So I'm just going to do an aside for a crash course here. So if you have 4 over x and you multiply it by x, that will equal 4x over x. And what happens to the x's? They cancel out and leave you with what is ever on the top. So we're going to apply that same kind of idea with these rational equations. So we're going to multiply it by everything. And we can do this as long as we do it to both sides of the equation. We can't do it with expressions because then we change the value of the expression, but we can do it with equations. So we're going to multiply everything by x minus 1 squared. Okay, so that's going to be 4 over x minus 1 squared times x minus 1 squared equals 9 over 4 times x minus 1 squared. Okay, so you're going to get this cancels out and leaves you with 4 equals 9 times x minus 1 squared over 4. Now, we want to get rid of the 4 as well. So we actually could have done this all in one step, but I'm going to show you it in 2 steps. So now we're going to multiply everything by 4 to get rid of that denominator of 4. Okay. So everything's being multiplied by 4. 4 times 4 is 16. And if we multiply that whole thing on here by 4, the 4s will cancel out and leave you with just what was on the top, 9 times x minus 1 squared. Now we could have done it all at once in that first step when we multiplied everything by x minus 1 squared. We could have actually multiplied everything by 4 times x minus 1 squared. But if we haven't gone over that unit, so take it slow, do one at a time, just get rid of all your denominators by multiplying by all your denominators, and you'll end up with what we have now. So now we gotta divide everything by 9. So we have 16 over 9 equals x minus 1 squared. You're then going to take the square root of both sides, and you're going to get plus or minus the square root of 16 over 9, which is 4 over 3, equals x minus 1. You're then going to add 1 to both sides, and that means x will equal 1 plus or minus 4 over 3. Okay, so now to give a final answer, we have to make that 1 over 3 to be over 3. We need a common denominator. So 1 is technically 1 over 1. So to make it over 3, it's the same thing as 3 over 3. So x is going to be 3/3 plus 4/3, which is 7/3. And I should say, it's going to equal 3/3 minus 4/3, which is negative 1/3. Okay, and those are your two answers, and that's how you solve quadratics using completing the square and by using the square root principle and to maintain precision. Very important. I'd like you guys to try those questions. Let me know if you have any questions. I hope that was helpful. All the best.